chi-squared. We have to know some formulas for chi-squared. We're going to need to know that chi-squared is equal to the summation of the observed minus the expected values squared divided by the expected values. We also need to know how to find the expected values, which is equal to the relative frequency times the number of times we're looking at the observed, how many times the observed have been observed. So what's nice is when you create these two tables, a generic two tables. So you use your types, you use your n value, you use your relative frequency, which is p, you use your expected frequency, which is e, and you figure these out for whatever the problem arises. In the same aspect, with the same problem, you're going to have your types, then you're going to have your observed frequency, which is O. Okay? It's usually given. Okay? And then we found our E, which is our expected frequency. Okay? And so we fill that in for however many types we have. And then we find the O minus E, and we put that here for however many types we have. Then we find the O minus E squared, so this piece squared, and we square it and we find all of those pieces. And then we take that O minus E squared and we divide it by the E, the expected frequency, and we find it for all the types. Okay? And when we're done with that, we can add up all of these, and we'll have the summation of O minus E squared divided by E, and that will give us our chi-squared. So in essence, chi-squared is equal to this. Okay? So, in addition to that, we're going to look at our df, which is equal to the number of types minus 1. Okay? And moreover, number of types is also looked at as R. So it's R minus 1. So df is equal to R minus 1. All right? So from there, you can look up your chi-squared depending on what your alpha is. Depending on alpha, it depends on depending on your alpha, depends on where you're looking at this chi-squared chart. Okay? So, remember, a chi-squared chart always starts off at 0, goes up and back down, and goes off to infinity. But underneath this curve, it'll never touch here. It'll never touch this bottom piece. And underneath this curve is always equal to 1. Okay? And so this piece right here is telling us at what point we're going to look. If we're looking at alpha is equal to 5%, right? Or the last 5%, then we're going to see basically a chi-squared at sub 0.05. Okay? And then you're going to see if your chi-square value lies within here, you would reject the null. If your chi-square value lies within here or on this side, then you do not reject the null. Okay? And that's basically how you do it. So let's do a problem. How much time is that taking? 5 minutes. I could do this problem in 10. Okay, so we have a problem in the book that has what's the problem state? States
Population by regions.
Population by regions. And the regions that they found were, and I'm going to use different things. So the regions they found were northwest, or no, northeast, sorry about that, or midwest, south, and west. So right here it tells us how many types are there. So right here we know that our DF is equal to 4 minus 1. So our DF is going to equal 3. So we know what our DF is already. What else do we know? How many, what was the population that they looked under? Total population was 250?
250, yeah.
So our total population was 250. Okay? So for each type, so in this case we have northeast, we have midwest, we have south, and we have west. So for each type, we have 250, 250, 250, 250. And then the relative frequencies that were given was 19% or 0.19, 22.9% or 0.229, sorry, that's a 9, 35.6% or 0.356, and 22.5%, which is 0.225. If that's our relative frequencies, to find our expected frequencies, we multiply the n times the p, and we get 47.5, 57.25, 89, and 56.25. With that, we're given the observes. So the observed, we look at it was given in the problem. What problem is this, by the way?
10 or 12.26.
12.26. In problem 12.26, it's given that we have the observes of 50, 43, 111, and 46. And we just found the expected values of 47.5, 57.25, 89, and 56.25. So what we now do is just step through our problem and use each this minus this to come up with this. And what we did is we found it to be 2.5 and negative 14.25. That's a 5, sorry. And 22 and negative 10.25. So then what we do is we square each of these to get 6.25. Okay, and 203.0625, and then 484, and 105.0625. So then what we do is divide that by this number. So after we square this number to get this, then we take this number and divide it. Take this number, divide it by E. So we take this number, divide it by this number to get this last number, which is 0.131579. Okay? And 3.54, 6943. Okay? And 5.4, 38202. And then 1.86, 7778. Okay? And then what I do is to find my chi-square, I just add these up. And I found it to be 10.984502. Okay? Well, we don't know anything about the chi-square until we look at how many times it's come up. So what is our DF? And so with a DF of 3, and in this problem we are looking at a percentage of 5%. So we want to look at this end. And we want to see, does it come up in this 5% area? Well, that means I have to look up a chi-square of 0.05, whereas my DF is equal to 3, which would imply, when I look up it in the chart, that that chi-square with the DF of 3 of 0.05 is equal to 7.815. So that means at this point on this graph, I have this chi-square piece out here, and out here at 0.05, all right, is going to be a value of 7.815. Okay, my value of chi-square is 10, so it's out here past the 7.815, which tells me that I reject, comes back right to here, that I reject the null. Ta-da!